In this video, we will generate the dataset and trend line of Gaussian function using the Taylor Maclaurin Series sum, the exponential function, the NORMDIST function, and the phi function. We begin with the Taylor Maclaurin Series sum, which is the summation of a times x to the power 2n, where the value of a is negative 1 to the power n all over factorial n times 2 to the power n. And the value of n is from 0 to infinity. So in this case, we can go as far as 16, which is good enough. And the coefficient will be equal to our formula minus 1 raised to the power n all over the quantity factorial n. Second term is 2 to the power n. 2 to the times 2 to the power n. And enter. Now we can complete the Taylor Maclaurin series sum. Array formula, series sum of the x values raised to the power 2n. 2n begins with 2 times 0, so 0, followed by 2 times 1, that's 2, 4, 6. So the starting is 0, and the increment is 2. And the coefficient will be this range. Enter. So here you have the trend line and the trend line polynomial of the Gaussian function to the 8th degree. We can check the polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, which is transpose 0 to 8. And this would be array formula of the x values raised to the power 0 to 8. Now we can enter LINEST. So this would be LINEST data y and data x. Enter. So here you have the trend line. So let's verify. X to the 0 has 1, x is 0, x squared is minus 0.5, x cubed is 0, x to the 4th is 0.123, x to the 5th is 0, x to the 6th is minus 0.182, x to the 7 is 0, and x to the 8 is 1.28 times 10 to the minus 3. We continue with the rest using the exponential function, which is array formula exponent of the x values. And the NORMDIST, this is equal to array formula NORMDIST of the x values. The mean will be 0, standard deviation is 1, and this is the cumulative is 0 because this is a probability density function. And the phi function, which is equal to array formula phi of the x values. And we'll calculate the polynomial regression coefficients. This is equal to LINEST data y and data x. This will be again LINEST data y and dot x. And this will be LINEST again. Finally, the phi function, LINEST dot y and dot x. Let's start manipulating the coefficient, the function, each function. We begin with the exponential. There's a negative zero point 0.5 multiplied to this minus 0.5 times, enter, and then there's a square that is to the power 2. Now they're all on the same trend line, and the polynomial regression coefficients are the same. We continue with the NORMDIST. This is multiplied by square root of 2 pi. So this will be times square root of 2 times pi. Enter. Now they're all on the same trend line. Their values are the same, and they're all in the same trend line. And finally, the phi function. The regression coefficients, they're also the same. And the phi function will be square root of 2 pi. So this is multiplied by square root of 2 times pi. Enter. All of them, all four of them are on the same trend line, and the regression coefficients are the same. So this completes the use of the phi function, the NORMDIST function, exponential function to generate the Gaussian function, and also the use of Taylor Maclaurin Series.